Okay, let's dive into this really fascinating world where artificial intelligence is getting a very specific, and I mean a very important, new job. We're not talking about your everyday chatbots here. We're talking about highly specialized tools built for high-stakes, high-pressure environments.
This isn't just some hypothetical. It's a daily reality for engineers and factory managers. In industries like aerospace or energy, a single decision can have massive consequences. And the tiny piece of information you need to make that decision, it's often buried deep inside thousands of pages of super complex documents.
So we're going to start by really looking at this core problem. The most critical information is often completely inaccessible right when you need it the most. And this isn't just, an inconvenience. It's a huge bottleneck that can seriously impact safety, efficiency, and, the bottom line.
I mean, just imagine the pressure. You've got an engineer working on a pressure vessel, and they have to be absolutely certain they're following the right safety standard. Or think of a factory manager on the shop floor who needs one single number right now from a ridiculously complex manufacturing execution system, which is basically the digital brain of the factory. A mistake could be catastrophic, but finding that one right answer is like searching for a needle in a haystack made of technical jargon.
So how do we fix this? Well, the answer seems to be building a whole new kind of AI. The best way to think about it is like a super-powered specialist librarian. Not one that knows a little bit about everything, but one that knows everything about one specific, super complex subject. So instead of a generic search engine that just dumps a list of links on you to sort through, developers are creating these custom question answering systems. They're basically chatbots that you can talk to in plain English. You can ask things like, what's the required pressure tolerance for this component, and get a direct, precise answer, not 100 search results to guess from.
Okay, and here is the major hurdle. To train these specialist AIs, you need a massive, and I mean massive, dataset of questions and answers that are specific to that field, like pressure vessel design. The problem? That dataset just doesn't exist. It's a classic chicken and egg situation. You can't train the AI without the data, but you can't get the data without an AI that's already trained.
Now this is where it gets really clever. Researchers came up with this ingenious method to create their own training data. They built a system that reads a statement of fact from a manual, something like, this rule applies to butt welding flanges. Then it uses AI to identify that key term, butt welding flange, and automatically flips the statement into a question, like, what product category does this rule apply to? And boom, the answer is butt welding flanges. It's a brilliant way to build that knowledge base from scratch.
And the results? Get this. In a real-world test on those complex pressure vessel standards, a system built exactly this way answered over 1,700 technical questions with 98.15% accuracy. For an engineer who's under the gun, that level of reliability is an absolute game changer.
Okay, let's move on to the next big challenge. Now that we have this AI assistant, what kind of brain should it have? You might think bigger is always better, right? Well, it turns out the answer is a little more nuanced from that.
It's really a classic trade-off. You've got the huge models with hundreds of billions of parameters. They're incredible at deep strategic thinking, but they're slow, they're expensive, and you often have to send your very sensitive company data out to the cloud. On the other hand, you have small models. They're the opposite, blazing fast, cheap to run, and they can operate entirely on-premise, which keeps all your data super secure. It's like choosing an engine. Do you really need the insane power of a Bugatti to do a city delivery, or is an efficient little van the smarter choice?
And if you just glance at the data, sure, bigger looks better. I mean, look at GPT-4o and Llama 45B. They're crushing the charts on general knowledge and math. But now, look down at the Llama 8B model at the bottom. For a factory that needs an instant answer on a production line, the speed and security of that smaller model running locally is way more valuable than the raw brainpower of its bigger cousins. It's all about picking the right tool for the job.
Okay, so we've got a specialized, right-sized assistant. It's fast, it's accurate, it's secure. But there is one more massive hurdle to clear. In a factory where safety is everything, how can an operator ever truly trust a recommendation that comes from a black box AI?
This is where a really critical field called explainable AI, or XAI, comes into play. Its entire purpose is to crack open that black box.
XAI isn't about getting a different answer from the AI. It's about understanding how the AI got to the answer it gave you in the first place.
You know, it's kind of like a math test back in school. Getting the final number right is important, sure, but showing your calculations is what actually builds confidence and proves you understand the process. The exact same thing is true for AI in these critical industries.
So the crucial point here is that XAI isn't just some nice-to-have feature. It is an absolute requirement. It's what builds trust, it's what ensures safety, and it's what makes these systems truly usable by people. It lets us see why the AI made a certain recommendation, which factors it thought were most important, and even how confident it is in its own conclusion.
So, when we combine all these pieces, the specialized knowledge, the right-sized performance, and that built-in trust, the final picture isn't some robot overlord that's coming to take over. No, it's something far more practical and, honestly, far more useful.
So what have we actually built here? When all these different pieces come together, what does this ideal assistant actually look like?
The ideal assistant is a really finely tuned instrument. It's this perfect balance. It's specialized for one job and right-sized to be efficient. It's secure, running on site to protect data. It's data augmented, using a cool technique called RAG to pull in real-time info. And, maybe most critically, it's explainable, so it can show its human partner exactly how it came up with an answer.
And this, right here, is the key takeaway. The whole point of this AI is not to replace the engineer or the factory manager, is to be their most powerful assistant. The AI handles all the tedious, time-consuming data sifting so the human expert can focus their unique skills on strategy, critical thinking, and solving the really complex problems.
So in the end, this whole journey shows us that the future isn't about having the biggest AI brain. It's about having the most efficient and trustworthy assistant. The most powerful AI isn't going to be a replacement for human expertise, it's going to be a collaborator. Which leaves us with the real question, are we ready to partner up?